Okay, all right, so we're going to look at different polygons today. Specifically, we are going to look at squares, rectangles, and squares, rectangles, and triangles all in the coordinate plane. So we're going to look at perimeter today. We're going to look at area today. But we're going to look at just some of those few simple shapes on the coordinate plane. Okay, so we're really not learning a whole lot new today. We're just kind of learning how to apply what we already know. Okay. All right, so looking here, I'm not going to fill in all of the polygon names. It is good that you know them. They're not necessarily going to be assessed at this point. 3 sides we all know is triangle. 4 sides. Quadrilateral is what we call it, okay? Because square is a specific type, rectangle is a specific type, so we call them quadrilaterals. 5 sides is pentagon. So if you just don't know any of these, I mean, you can fill them in real quick. I mean, it's not that big of a deal. 6. The difference between 6 sides and 7 sides, some people mess up. Do you know 6 and 7? 6 is a hexagon, and then 7 is a, not sept, heptagon. Heptagon. Okay? So hexagon, heptagon. Then we have 8, which you guys all know, right? Octagon. 9 is a tough one. Nonagon. Good. Nice. Okay. 10. Decagon. And then we run out of cool names and we call all the rest of them ingons. Ingons. So if it had like 12 sides, you would call it literally a 12-gon. Like N-G-O-N. So you would write 12-G-O-N, 12-gon. Okay? Okay, let's look at concave and convex. Okay? Sorry? 5 sides was pentagon. Okay, so concave and convex. So the easy way to remember concave and convex is caving in on itself. Right? So a concave polygon kind of caves in on one side. That's the easy way to tell when you're looking at it. The technical definition of concave is if I can draw a line. So let me get a different color here. If I can trace one of the sides in a straight line and extend that out and it will intercept one of the other sides, that's how I know it's concave. Okay, like this convex one over here, I couldn't do that with any of the sides, right? None of these sides will intercept another side. So that's why I know it's convex. Okay. Generally, we can tell pretty easily by looking at them. Concave is caving in on itself, and then convex is the other. Okay, so just some technical definitions. Now let's jump into what we're really looking at. Let's see. For sake of time, let's just do the first 2 on both sides. Okay, so we're just going to do quadrilateral PQRS and triangle BPA. So we're not doing AQD or DRC or what's the last one? CSB. Okay, so just go ahead and work on those together with your groups. Go ahead. Okay, so let's start with the square. Okay, let's start with the square. How do I find the area of a square? Base times height. Good. So area of a square is base times height. Guys, are you with me? Okay, so my base is 1. What's wrong with my stylus? There we go. My base is 1, my height is 1, so 1 times 1 is just 1. Perimeter of a square, all I'm doing for a perimeter is just adding up the sides, right? So 1, 1, 1, 1 is 4. Okay, so PQRS, the perimeter is 4. Triangle, let's go for the triangle. So we're looking at this particular triangle, BPA. BPA. How do you find the area of a triangle? Good, 1/2 base times height. Then I can count the base and the height, right? The base is 1, 2, 3, 4 units. The height is 1, 2, 3 units. So 1/2 times the base of 4 times the height of 3. So half of 12 is 6, right? So I get an area for that triangle of 6. Okay, and then I can also find the perimeter of the triangle. In order to find the perimeter of the triangle, what do I need to find first? Yeah. The length of the other side. Okay, which is side AB, right? So I need to find the length of this side over here, AB. Do we have a way of finding the distance of this line on a coordinate plane? Okay, so remember we kind of turned the Pythagorean theorem into the distance formula. Okay, so we're kind of looking, I'm just going to write it in terms of the distance formula, but yes, but the Pythagorean theorem is basically the same thing. So we have the distance, or actually I'm going to call it, instead of distance, I'm going to call it AB. Okay, AB equals the square root of 3 squared, which is 9, plus 4 squared, which is 16. So the square root of 25, which is just 5. Oh wait, no, this is just AB. Okay. Can I move this? Oh my gosh. I don't know what just happened. Okay, let's just not do that. Alright, so I'm going to, yeah. That's AB. That's not the perimeter of the triangle, right? I can't move it. I don't know how to move it on explain everything. Notability, I know you can do that. So triangle the BPA. So we found this is 5. So I just add up all my sides, right? 5 and 4 is 9 and 3 is 12. Okay, so my triangle, the perimeter there is just 12. Okay? Okay, so that's basically it today, guys. That's basically what we're learning today, is how to find the perimeter and area. Okay, I know you guys already know the formulas for area. So the thing that you really need, is just how to apply now, applying that distance formula to actually find the sides of polygons that you don't know. Okay? All right, so let's go ahead to the back page. I'm going to let you guys go ahead and do all of them. I'll give you about 10-ish minutes to do all of them. We'll go over them and be done for the day. Okay? All right, rock and roll. All right, let's look at 1. Okay, let's look at 1. So I already drew my triangle. I know that the base is 2. I know the height is 1, 2, 3, 4, 5, 6. So I can find the area, right? Everybody with me, please? Okay, so we can find the area with what we have right now. So I have 1/2. The base is 2. The height is 6. Half of 12. The area is 6. Okay, let's find the perimeter. But in order to find the perimeter, I need the hypotenuse, that third side. So I can do my distance formula. Okay, it's going to be the square root of 2 squared is 4, plus 6 squared is 36. So that's the square root of 40. Which, after much debate, the square root of 40. Just kidding. Get it? It was funny. You guys were talking about it for like 5 years. All right, is what? No, 6.3, right? Not 3.6. Okay, so this side over here is 6.3. Now I can add them all up. So 6 and 2 is 8, and 6 more is 14.3, right? So the perimeter equals 14.3. Okay. Number 2 is even easier because it's a square. So each side is 3. So my area, 3 times 3 is 9. My perimeter, add them all up, is 12. Any questions about that one? Pretty straightforward. Okay, coming down here. Let me zoom out a little bit. Okay, so find the perimeter of ABD. Okay, so we have AB. That's 1, 2, 3, 4, 5. BD is 1, 2, 3, 4, 5, 6. Okay, and then I need the hypotenuse. So square root of 25 plus 36 is 20, 50, 61. Square root of 61. What's the square root of 61? 7.8. It is. So that's 7.8. So 5 plus 6 is 11 plus 7.8 would be 18.8. Okay, so we get 18.8 there. The perimeter of BCD. Okay, that's the bottom triangle now. Okay, so we know these two sides. So if you can kind of look, if I look at the height right here, those are both right triangles. So both of the hypotenuses are going to be the same, right? So finding the distance, and I can use the distance formula here, right, to find the distance between B and C. if I would do 2 minus -1 squared plus -1 minus a -5 squared. Okay, so that would be plus a positive, that's 3 squared, that's 9. Okay, back here plus a positive, that's 4 squared is 16. So that's the square root of 25, which is just 5, right? So I know that this hypotenuse here is 5. This hypotenuse here is 5. So both of those sides are 5. The base is 6. So that would be 16. So I get a perimeter of 16 for BCD. Perimeter of the quadrilateral ABCD. So now I have all the sides. So now I'm counting up 5 plus 5 more is 10 plus 5 more is 15 plus 7.8 would be 22.8 for the perimeter of the quadrilateral. And then we move to areas, which are a little bit easier, right? Because I know all of the bases and heights. So area of the top triangle for ABD, number 6. Base is 6, height is 5. So I have 1/2. Base is 6, height is 5. Half of 30 is 15. So the area of that one is 15. Area of the bottom triangle, you got to be careful, right? So I have to find the exact height. And the height is in here in the middle. So the base is 6, but the height here is 1, 2, 3, 4. Okay? So I have 1/2. The base is 6. The height is 4. So you can't just count one of the sides and make that be the height. All right? I wouldn't use 5 as the height. Y'all with me there? Okay, because that's a very common mistake. Okay, so half of 24 would just be 12 for my area there of BCD. And then to find the area of the quadrilateral, right now we really only know how to find the area of squares and rectangles, so that's an odd quadrilateral. So a simple solution there is add the areas of the two triangles that you already know inside. Right, that top triangle is this 22.8 number, or no, 15, sorry, that's the perimeter. The area of that top triangle is 15, the area of that bottom triangle is 12, so the area of the quadrilateral will be 27.